Bismillahirrahmanirrahim. Assalamu alaikum and welcome to my YouTube channel Soil Agri GIS. I am Dr. Humair Ahmed Malik, a soil scientist with expertise in GIS and remote sensing. As far as this YouTube channel is concerned, it is dedicated to explore soil analysis, GIS, and remote sensing for soil health assessment and its management. As we face global issues of soil degradation and climate change, technology adoption plays an important role for sustainable farming. Whether you are a student, researcher, or an enthusiast, you will find valuable insight here. Don't forget to subscribe and turn on notification button for latest videos. GIS is actually Geographic Information System. Geographic Information System is a computer system capable of capturing, storing, analyzing, and displaying geographically referenced information. Geographically referenced information मीन ये हम इसमें information store कर सकते हैं with special reference to its location. ये हमें बताता है कि उस location पे कैसी condition है. It is data identified according to the location. GIS के components अगर देखे जाएं तो GIS includes procedures, operating personals, and special data that go into the system. Special data is actually coordinates. ये जो हम GPS से coordinates record करते हैं ये उसकी location होती है. इसको हम special data भी बोलते हैं. वैसे तो there are 4 types of the data: vector and raster data, special data, and attribute data. But the most important data which are used in the agricultural purposes include spatial data and attribute data. Spatial data is again coordinates of that particular location, and attribute data is the data which was recorded for those uh, coordinates or for that particular location. Data analysis as far as data analysis tools are concerned, these are provided by GIS softwares are geostatistical analysis, spatial data analyst. GIS makes it possible to integrate information that is difficult to associate it through any other means. GIS is combination of mapped variables to build analyze new variables. इसमें हम एक वेरिएबल को या 2 वेरिएबल्स को यूटिलाइज करते हुए तीसरे वेरिएबल्स के बारे में इंफॉर्मेशन भी जनरेट कर सकते हैं. इसमें हमारे पास को-क्रिकिंग की टेक्निक्स आ जाती हैं. GIS is the most useful when used to perform data analysis. अगर हम देखें हिस्ट्री ऑफ GIS तो GIS was first developed in North America, US, and Canada in mid-1960s. Dr. Roger F. Tomlinson coined the term Geographic Information System. He is also known as father of GIS. इन्होंने फर्स्ट टाइम कंप्यूटराइज्ड जियोग्राफिक इंफॉर्मेशन सिस्टम दिया था और ये एक जियोग्राफिक डेटाबेस जनरेट किया था जो कि अभी भी यूज हो रहा है इन द म्यूनिसिपैलिटीज ऑफ द कनाडा फॉर लैंड प्लानिंग. As far as components of GIS are concerned, it includes हार्डवेयर. जैसा कि हमें पता है सिस्टम कंप्यूटर सिस्टम GPS ये सारे हार्डवेयर हैं. सॉफ्टवेयर और software like QGIS, ArcGIS, different software packages हैं जो use होते हैं for data analysis. There are various procedures for creating informations using GIS. For example, जिस तरह हम common statistics में statistical analysis of variance यूज़ करते हैं या मुख्तलिफ procedures यूज़ करते हैं, इसी तरह GIS के अंदर भी मुख्तलिफ procedures यूज़ होते हैं. डेटा वेरी इंपॉर्टेंट कंपोनेंट. जाहिर सी बात है, हमारे पास डाटा होगा तो हम उससे इंफॉर्मेशन जनरेट कर सकते हैं. और यूज़र sensible user is always necessary for creating data or for doing analysis. As far as function of GIS, सबसे पहले जो इम्पोर्टेंट चीज़ है दैट इज डाटा एक्विजिशन. डाटा हासिल कैसे किया जाता है? सबसे पहले जो डाटा GIS में यूटिलाइज होता है दैट इज जियो रेफरेंस डाटा. जियो रेफरेंस डाटा मीन उस पर्टिकुलर लोकेशन से रिलेटेड होता है. इसमें हमारे पास हम वहाँ से कोऑर्डिनेट GPS की मदद से कोऑर्डिनेट्स ले लेते हैं और बेस मैप्स एटसेट्रा. एंड एट्रीब्यूट डाटा, फॉर एग्जांपल अगर हम एक जगह से सॉइल सैंपल लेते हैं, वहाँ से हम कोऑर्डिनेट्स ले लेते हैं, तो वो हमारा वहाँ पे स्पेशल डाटा हो गया. और उसके जब हम एनालिसिस करते हैं तो हमारे पास जो न्यूट्रिएंट स्टेटस आता है उसको हम वहाँ का एट्रीब्यूट डाटा कहेंगे. Data management, making data to be understood by GIS. Data was particular. Database management is actually making that data understandable by GIS. Then हमारे पास स्पेशल मेजरमेंट्स आ जाती हैं. डिफरेंट किस्म की स्पेशल मेजरमेंट्स हम यूज़ करते हैं और एनालिसिस यूज़ करते हैं. उनमें क्रेजिंग होता है, IDW इनवर्स डिस्टेंस वेटिंग होता है और को क्रेजिंग होता है. फिर इनकी आगे मुख्तलिफ डिफरेंट किस्म की टाइप्स हैं. ग्राफिक आउटपुट एंड विजुअलाइजेशन. एट द एंड हम ये सारा कुछ मैनेजमेंट करने के बाद, स्पेशल एनालिसिस करने के बाद हम जिस चीज़ पे पहुंचते हैं दैट इज ग्राफिक आउटपुट ऑफ द आर विजुअलाइजेशन. तो उसको हम जो हमें चीज़ आउटपुट मिलता है दैट इज डिजिटल मैप. Objectives of GIS includes maximize the efficiency of planning and decision making. Decision making and planning में हमें with geo referenced information efficiently हम काम कर सकते हैं. Provide efficient means for data distribution and handling. GIS makes data distribution and handling easier. If you are going to provide data regarding nutrient status, you have to just give a few maps to the farmers or to the policy making agencies. Elimination of redundant database, minimize duplication. जो database है इसमें कोई repetition नहीं होती. Provides efficient means for data distribution and handling. It has capacity to integrate data from different sources. Complex analysis query involving georeference data. As far as importance of GIS based inventorying is concerned, geospatial data are better maintained in standard formats. Geospatial geospatial better decision in policy making, precision agriculture and site specific nutrient management. अब मैं आपको कुछ केस स्टडीज शेयर करूंगा आपके साथ जिसमें हमने स्पेशली वेरिएबल सिंक न्यूट्रिएंट टेक्नोलॉजी इन एप्पल ऑर्चर्ड्स ऑफ हमारी रीजन इन पाकिस्तान. First of all, I will go that why we selected fruit orchards. Actually, the average yield of fruit orchards in Pakistan is very, very low. That is about 9 tons per hectare. It is very low, and the situation is very alarming when it is compared with the world's average yield of 25 tons per hectare. With this lower average yield, Pakistan ranks 30th in world fruit production. There are many reasons for this lower average yield, but one of the most important or one of the major reason is nutrient deficiency and low bioavailability of the nutrients. So the lower yield, this site can be managed by. So why we selected food orchards for this study? Average yield of fruit orchards in Pakistan is very low, that is 9 tons per hectare. The situation is very alarming when average yield of Pakistani fruit orchards is compared with the world's average yield, that is 25 tons per hectare. But with this lower average yield, Pakistan ranks 30th in food production. There might be several reasons for this lower average yield, but one of the most important or one of the major reasons for this lower yield is nutrient deficiency and low bioavailability of the nutrients to the crops. If we compare the average yield of Pakistan with different apple producing countries, it is around 4 times lower than India and 6 times less than Netherlands and around 3 times less than Australia and similarly 4 times less than Brazil and Germany, which are major other apple producing countries in the world. Maximum yield obtained in apple producing country, that is Slovenia, is 69.85 tons per hectare. And if we compare it with the Pakistani average yield, there is a gap of 62 megagram per hectare. Pakistan ranks 35th in apple production with this lower average yield. As far as role of GIS is concerned, geostatistics and GIS is concerned in nutrient management, are why the geostatistics and GIS becomes inevitable for nutrient management. In Pakistan, nutrients are recommended on provincial basis. There is uniform recommendation of nutrients, whether the soils have, while the soil have differential nutrient status. For example, if we compare the nutrient status of the soils of Murray region with the deserts of Thal and Dera Ghazi Khan, then the soils of the Murray are fertile and has higher organic matter content and nutrient status as compared to deserts. But in Pakistan, usually the recommendation comes on provincial basis, and uniform recommendations leads to low or higher use of fertilizers or nutrients, which in return leads to loss of nutrients and or lower yield due to excessive use of fertilizers or the nutrient loss, and then while lower yield in the areas where nutrient status was already low. Observation of variables from place to place, each and every corner of the area is not possible due to the laborious soil sampling and usual statistical techniques. Because classical statistical techniques, only observe the changes within a field or an experimental area. When coefficient of variance is higher in the studies, then geostatistical and spatial analysis are used techniques for analyzing data. Application of geostatistics and GIS is inevitable for nutrient management. These are various semi-diagram models or and ordinary grading used for uh, digital mapping of the nutrient status. The terminology for spatial description is which is used in the semi-variogram model. I will be uploading a detailed video in which we will study semi-variogram modeling. First of all, there is a nugget variance which represents error due to measurement or special source. This L refers to the maximum semivariance that represents the variation. Then range indicates the distance beyond which sample behave independently. This is semi-variogram model on the right side, showing its various components. What were the research gaps in the area? There, uh, there were there was not never undertaken any geo-referenced survey, and database for bioavailable micronutrient in area was unavailable. GIS-based digital mapping for plant available nutrients in the area was never done. Zinc nutrition assessment in the apple orchards was never done. Our hypothesis was that soils that have high degree of spatial variability in the zinc content can be better managed using site-specific nutrient management zones. These are various semi-variogram models which were developed for different nutrients: zinc, copper, iron, manganese at 3 depths. Here are the conclusions which we drew from the semi-variogram modeling. Bioavailable zinc, copper, iron, and manganese were moderately spatial dependent in the surface and strongly spatial dependent in the subsurface and lower soil depth. Bioavailable iron was moderately spatial dependent at 3 soil depths. However, negative-to-sill ratio decreased with the depth. Lower negative-to-sill ratio indicates the stronger spatial dependence as compared to the higher negative-to-sill ratio. Spatial dependence in the surface and lower soil depth was maintained by the inherent soil factors like parent material and inherent micronutrient content. After semi-variogram modeling and establishment of strong to moderate spatial dependence, these were the digital maps created by ordinary kriging indicating differential nutrient status in apple producing area of Murray region. These are digital maps created for iron content and manganese content. Then an experiment was carried out to examine the to recommend the site-specific nutrient management on regional basis. We selected soils with different zinc levels that were low, medium, and adequate. We selected 6 orchards, 2 from the low zinc status, 2 from marginal and adequate nutrient status. We applied three treatments. We applied 4 treatments with 3 applications, and treatments were 250 gram nitrogen, 225 gram phosphorus, and 225 gram potassium, which is recommended NPK for apple production in the area. We applied 20 gram zinc per plant plus recommended NPK and then 30 and 40 gram zinc per plant along with recommended NPK. Highest yield was observed with the application of 30 gram zinc per tree in the soils having low indigenous zinc status, while highest yield was observed with the application of 20 gram zinc in the soils having medium and adequate indigenous zinc status. Interactive effect between indigenous zinc status and applied zinc level was significant which indicated that soil showing special variability can be better managed by using GIS. Now, what is remote sensing? I have included first slides were related to introduction about GIS, and I shared a case study with you people. Now, what is remote sensing? After sharing information regarding GIS, its introduction, and its and quoting one case study regarding application of GIS for regional based site specific nutrient management, now it's time to introduce remote sensing. Remote sensing, as the name is indicating, remote meaning far away and sensing meaning observation. The science of obtaining information about object without being in physical contact with object or sensor is called remote sensing. A remote sensing is a science of obtaining information about an object without being in touch with it. इसी तरह यह जिस तरह की एक्सरे मशीन में आपने देखा होगा कि एक्सरे मशीन ह्यूमन बॉडी को टच नहीं कर रही होती, लेकिन उससे रिलेटेड इंफॉर्मेशन हम गैदर कर लेते हैं। तो अभी हम आते हैं कंपोनेंट्स ऑफ रिमोट सेंसिंग। रिमोट सेंसिंग में जो पहला कंपोनेंट है दैट इज एनर्जी सोर्स। फॉर एग्जांपल इन दिस फिगर A, sun is the energy source, while B, it's emitting radiation through atmosphere. These radiations interact with the objects present on the Earth. Then a satellite in the space records those changes in the energy. Then transmission, reception, and processing at E, and then interpretation and analysis of those imagery obtained from satellite, and then its application. रिमोट सेंसिंग की दो किस्में होती हैं, एक है एक्टिव रिमोट सेंसिंग और दूसरी है पैसिव रिमोट सेंसिंग। पैसिव रिमोट सेंसिंग में जो एनर्जी का सोर्स है वो सन होता है, सनलाइट, और उनको हम उससे जो रेस ऑब्जेक्ट से रिफ्लेक्ट होकर जाती हैं उनकी ब्राइटनेस को स्टडी कर लेते हैं। इसी तरह जो दूसरी टाइप ऑफ रिमोट सेंसिंग है इट्स एक्टिव रिमोट सेंसिंग। एक्टिव रिमोट सेंसिंग में इट रिक्वायर्स पावर टू ऑपरेट। इसमें जो सनलाइट की रेडिएशंस नहीं होती, हम माइक्रोवेव्स या एनर्जी सोर्स अपना यूटिलाइज करते हैं। बेसिक प्रोसेसेस अगेन यहाँ पे वही हैं, डेटा एक्विजिशन, एनर्जी प्रोपगेशन, processing, conversion of that energy pattern to image, then analysis, quantitative and qualitative, accuracy assessment, radiometric and geometric correction, information distribution to users. Application in agriculture, इसमें हम क्रॉप एकरेज एस्टिमेशन, हमें पता चल जाता है कि कितने एरिया पे कौन सी क्रॉप कल्टीवेट हो रही है, ग्रो हो रही है, और कौन सी, और हम इससे यील्ड भी कंपेयर करते हैं। फॉरकास्ट एस्टिमेशन भी होती है, और सॉइल जो क्रॉप हेल्थ है उसको भी हम मॉनिटर कर सकते हैं। अगर हम देखें तो ये हमें जो रिमोट सेंसिंग और जीआईएस की टेक्नोलॉजी है, इससे हमें जो रियल टाइम इंफॉर्मेशंस है वो मिलती हैं। टाइमली अवेलेबिलिटी ऑफ क्रॉप स्टैटिस्टिक्स फॉर डिसीजन मेकिंग एंड प्लानिंग, क्रॉप ग्रोथ मॉनिटरिंग, then regular reports regarding total area under cultivation. रिमोट सेंसिंग से रिलेटेड हमने एक स्टडी की थी, प्रिडिक्शन ऑफ सॉइल ऑर्गेनिक मैटर यूजिंग जीआईएस एंड रिमोटली सेंस इंडाइसेस in shale and sandstone derived soils. Soil organic matter is a property to be considered for precision agriculture and environmental management. It improves soil health, nutrient supplying capacity, fundamental pointer of soil health and use. Soil organic matter plays a significant role in the aggregate stability. It improves the water holding capacity of the soil. Worldwide carbon content in the soil ranges from 2,500 gigatons organic carbon, 1550 gigatons, and inorganic carbon is about 950 gigatons. Soil has 3.3 times greater carbon content than atmosphere. It means soil जो है वो मेजर कंट्रीब्यूटर भी हो सकता है for global warming. Organic carbon content in the soil up to 1 meter depth is about 30 tons per hectare in arid climates. This study was carried out on a farm having area of 0.94 square kilometer. It was actually a research station having diverse vegetations. इसमें ट्रीज भी थे, डिफरेंट किस्म के ट्रायल्स चल रहे थे. इसमें से हमने 93 जियो रेफरेंस सॉइल सैंपल्स कलेक्ट किए और सॉइल ऑर्गेनिक कार्बन डिटरमिन की. Soil organic carbon was converted to soil organic matter by multiplying with factor of 1.724. इधर से हमने उन्हीं जिन डेट्स में सैम्पलिंग की थी उन्हीं डेट्स के सैटेलाइट इमेजेस लिए. Landsat 8 images with special resolution of 30 meters were collected. Radiometric correction followed by atmospheric correction was carried out, and we calculated NDVI, normalized difference vegetation index, LSC. This is the geographical location of the study area, and sampling points were indicated. Then we calculated. Then we completed digital mapping of organic matter using IDW and grading. If we see here, then IDW was more site-specific in organic matter estimation as compared to ordinary grading. Then we calculated NDVI, normalized difference vegetation index, employing the satellite imagery. This is LSE, land surface emissivity on the left, and land surface temperature on the right side. This form also have uh, some buildings in it. That's why some area is indicated by red color, and temperature range from 25 to 31 degrees Celsius. These were relationship from between soil organic matter content and normalized difference vegetation extracted normalized difference vegetation index. This is inverse relationship between soil organic matter content and land surface emissivity, which indicates decrease in land surface emissivity with the increased organic matter content. And as organic matter content were higher in this graph, then normalized difference vegetation goes on increasing. Actually, if soil organic matter content is higher, it means that soil health is more strong as compared to lower organic matter, soil having lower organic matter content. There was a inverse relationship between land surface temperature and organic matter content in the soil. Definitely, if soil organic matter content are higher, then vegetation is healthier in the area and there is lower land surface temperature. There was inverse relationship between land surface temperature and normalized difference vegetation index. Conclusion: the soil organic matter was found to be positively related to normalized difference vegetation index. and negatively related with the land surface temperature and land surface emissivity. The geostatistical analysis revealed that based on the established relationship, remote sensing indices like NDVI could be used as indirect measure of soil organic matter status and that further indicates soil health status. Enhanced कार्बन सिक्वेस्ट्रेशन हम अगर इस केस स्टडी को कंक्लूड करें तो सॉइल ऑर्गेनिक मैटर जो है वो पॉजिटिवली रिलेटेड था टू एनडीवीआई एंड नेगेटिवली रिलेटेड विद लैंड सरफेस टेम्परेचर एंड लैंड सरफेस एमिसिविटी। जैसे जैसे सॉइल ऑर्गेनिक मैटर कंटेंट हाई होंगे सॉइल में तो उससे लैंड सरफेस टेम्परेचर और लैंड सरफेस एमिसिविटी डिक्रीज होगी। तो इसका मतलब ये है कि अगर हम कार्बन सिक्वेस्ट्रेशन करते हैं तो उसका इन रिटर्न इफेक्ट ये होगा कि लैंड सरफेस टेम्परेचर डिक्रीज होगा। Geostatistical analysis revealed that based on established relationship, remote sensing indices like NDVI could be used as indirect measures of the soil organic matter status and further indicate soil health status. Enhanced carbon sequestration will not only lead to increased vegetation but also will play a role in amelioration of global warming. Thank you very much for watching. Stay tuned for more hands-on tutorials and interesting videos related to science, soil science. Thank you very much.